In this video tutorial, I will show you how to define more complex lens edge geometries, such as chamfers and flanges in our optical system, as you can see here in the smartphone lens. First, I will show you how to define chamfers, which you commonly see, for example, in camera lenses. To define chamfers, we go here to the optical design editor, to the lens where we want to add the chamfer, for example, here this first singlet lens, and then we click here on the small plus icon, and in this lens settings editor on the right side we see those non-optical surface properties. First we need to activate this enable checkbox in order to activate non-optical surfaces at all. The second option is symmetry. If we enable the symmetric checkbox, the chamfers on the first and on the second surface will be identical. So let's activate here this checkbox. Then in the next section you can define how the chamfer geometry is specified. For example, we can define a 45-degree chamfer by height or by diagonal, by height and length, or by angle and height. So let's use 45 degrees by height. And here for the height we can specify the height in millimeters. So let's use 1.5 millimeters and then click on update. And now we can see that here to the singlet lens, this chamfer has been added. And also here in this 3D view or in this drawing, you can see that here this chamfer has been added. It's important to note that the chamfer always starts at the clear aperture. This means the overall lens diameter increases by the size of the chamfer, but the clear aperture itself remains always unchanged. Now let's define a second chamfer, in that case an asymmetric chamfer to this second lens here, to this doublet lens. We click again on this plus icon, we enable the chamfer, we disable symmetric checkbox because we want an asymmetric chamfer, and for chamfer type we specify, for example, height and length. And now we can specify the height and length for the first chamfer on the left side, for example 0.5 millimeters for height and length, and for the second chamfer on the right side we insert 15.5 millimeters and 5 millimeters for the length and 15.5 for the height. Now click on update, and what we can see is here that this asymmetric chamfer has been added, here with 0.5 millimeters height and here with 15.5 millimeters height. It's also possible to define chamfers for cemented elements. In that case, the chamfer would be applied to the outer surfaces of the lens and not to the cemented surface. Besides chamfers, we can also define flanges. For example, in injection molded lenses, flanges are often used for mounting purposes. Here you can see, for example, this flange. To define flanges, again, we go to the lens where we would like to add the flange, for example, to this lens here. We click on this plus icon, and then again here, under non-optical surfaces, at the very bottom we see the flange size. We can specify here, for example, 1.5 millimeters. We click on update, and now we see that here this 1.5 millimeter flange has been added to this lens. We can also have asymmetric flanges for doublet lenses. For doublet lenses we have even more options how we can define the flanges. It's important to note that the flange also starts at a clear aperture. This means the overall lens diameter increases by the size of the flange, while the clear aperture itself remains unchanged. So it's basically the same behavior as with the chamfers. Adding chamfers or flanges does not affect the optical surfaces. In summary, this means by adding chamfers and flanges we are able to design our optical system to reflect how it will look after manufacturing, including the real geometric dimensions of the optical elements. and especially for lens optimization in QUADOA, adding chamfers and flanges has the advantage that edge thicknesses or edge airspaces are taken into account, and this leads to a more realistic optimization result, since the optimization is based on the real physical dimensions of the optical system, including the geometries outside the clear aperture. Yeah, thanks for watching.